Hello everyone, my name is Vinod Sinaya and I'm here today to talk to you about the radioactive pollution which is happened in Bukit Merah, Perak on 1982. I'm representing Group A. My group members are Sri Raghavendra Rao and Yatesh Ravichandar. We are from class DAM 4B. Okay, now I'm going into the story. Okay, firstly introduction for the radioactive pollution which is happened in Bukit Merah on 1982. Details about the issue. The 1982 Bukit Merah radioactive pollution is a radioactive waste pollution incident in Bukit Merah of Kinta district in central Perak, Malaysia. The outcome of the pollution case took several years to complete with no acknowledgement of responsibilities from the companies involved despite the closure of factory in the 1994 that become the source of this pollution. A rare earth extracting company named Asia Rare Earth Sandran Berhad ARE was established in 1799 for yttrium extraction in Bukit Merah, Perak, with the biggest shareholders for the company was the Mitsubishi Chemical Industries Ltd and Bay Minerals, both with 35% share, together with Tabung Haji and other Bumiputra businessmen owning lesser shares. In 1982, the newly established company began to extracting yttrium from a mineral named monazite, which contains different earth elements with radioactive including thorium and uranium. Since the company are starting its operation, residents from a nearby town of Papan began to complaining unpleasant outdoor and smoke from the factories where they also had breathing difficulty as a result of the pollution. The residents later recovering in 1984 that the extracting company of ARE had built a waste channel to a disposal site near their town under the consent of the state government of Perak. Okay, now I'm show some pictures of the Bukit Merah radioactive pollution places. These are some photos of the radioactive infect areas. Imagine that you are one of the engineer in the factory. If I were an engineer on there, I would not let this pollution happen on there because the biological effect on the precipitations of internal radionuclides depends largely on the activity and distribution of the bio and the rate of radionuclide removal, which in turn depend on its chemical form. The biological effects may also depend on the chemical toxicity of the precipitated material, independent of the radioactivity. Some radionuclides may spread generally in the body and be eliminated rapidly, as in the case of treated water. Some organs concentrate certain elements and thus radionuclides variations of those elements. This action may lead to a lower removal rate. For example, the triode glide absorbs most of the percentage of iodine that enter the body. If large amounts of radioactive iodine are inhaled or ingest, the triode may be paralyzed or destroyed, while the tissue are affected at a lower rate.
Now I'm going to present contents, which part 1, Engineering Management Society, and the first title is Law and Standard in Engineering Practice. So the Occupational Safety and Health Act 1994 (OSHA) creates a legal basis for promoting and stimulating and promoting high levels of workplace safety and health. Responsibility for occupational safety and health in the workplace is shared between employers and employees. According to Act 1045, because of employers are those who provide a hazardous work environment in the workplace, and employees are the one who have to work in these heads. Employees and employers, self-employed person, designer, manufacturer, importers and suppliers of plant or material all have responsibility under OSHA 1994. National Council for Occupational Safety and Health duty to formulate safety and health policy. Appointment of safety officers and health in certain industry classes. The enabling of a safety and health committed in the workplace and the use of approved industry code of practice, evidence of compliance with safety and employee provision are all highlights of the Act. The next is a legal and regulation obligation for public safety, workplace safety and protection of environment. Atomic energy activities in Malaysia, including radioactive waste management, are regulated under the Atomic Energy Licensing Act 1984. Pursuant to Section 3 of Act 304, the Atomic Energy Licensing Board Lembaga was established on 1 February 1985 as the enforced body for the implementation of Act 304 pursuant to Section 12(1)(b) of Act 304. No person shall deal with, possess and or dispose of any radioactive material, nuclear material, fissile object or irritation apparatus unless it is a valid license. A valid license in accordance with the provision under the radiation protecting licensing regulation 1986 should be obtained from the appropriate authority for the disposal of radioactive waste. Pursuant to Section 12(1)(b) of Act 304, no person shall deal with, possess or dispose of any radioactive material, nuclear material, prescribed substance or irritation apparent unless it is a lawful license. A valid license in accordance with the provision under the Radiation Protection Licensing Regulation 1986 should be obtained from the appropriate authority for the disposal of radioactive waste. For the purpose of control and regulation of radioactive waste, the Atomic Energy Licensing Radioactive Waste Management Regulation 2011 also provides for several mechanics as follows: control of radioactive waste generation, reuse and recycle, return of used sealed resource, transfer to radioactive waste management facility, waste and disposal of radioactive waste. Generally, radioactive waste in Malaysia is generated from activities such as medicine, manufacturing, research, agriculture, mineral exploration and processing, and oil and gas exploration. Radioactive waste also includes adding radioactive material that is certified, no longer used and declared as radioactive waste. Malaysia also has research reactors that use nuclear material as nuclear fuel. Nuclear fuel released from research reactors following irritation that can no longer be used in exiting from due to depletion of nuclear fission, poison formation or radiation damage is known as used nuclear fuel. Accordingly, the rules and responsibility of the government as well as the owner of generator or radioactive waste and used nuclear fuel must be clearly defined to ensure the safe and controlled management of radioactive waste and used nuclear fuel. Objective of the National Radioactive Waste and Used Nuclear Fuel Management Policy Statement: to ensure that radioactive waste and used nuclear fuel are managed and disposed of in a safe, controlled and sustainable manner to protect the public and not burn future generation and the environment through the setting of responsibility, resource allocation and improvements in the legal and industrial framework. In addition, this policy aims to increase public confidence in the management of radioactive waste and used nuclear fuel in Malaysia. The National Radioactive Waste and Used Nuclear Fuel Management Policy Statement applies to radioactive waste generated from medical activities, manufacturing, research, agriculture, mineral exploration and processing, oil and gas exploration and other activities as well as used nuclear fuels in Malaysia. This National Radioactive Waste and Used Nuclear Fuel Management Policy Statement covers a comprehensive policy on the radioactive waste management process from radioactive waste generation to disposal and institutional control over radioactive waste disposal facilities. Next is duties of profession, employees and society. Controller obligations to employer are just one example of professional responsibilities. The responsibility may seem the conflict with personal and social responsibility at certain times. Personal responsibility is a broad obligation to others. The majority is shared by everyone. Honesty and concern from others. Social duty is that which applies to the whole of society. We owe community money because it has helped us when we need it, for example, environment activists, peace activists and national defense. The professional duties are responsibilities shared by members of particular profession. Usually the meaning of responsibility exists. Professional of abdication and duties motivate towards achieving career development, maintaining continuity in attendance, employee in volatile market condition. Project managers are actively involved in their career development, believes are strives and significantly improve the marketability of their professional views and knowledge. Project managers are interested in promoting their experience and expertise in a professional context. Critically reflect on employment condition, the level of particular fairness and interaction with stakeholders, and perhaps more importantly on their individual contribution to their work. Project manager tend to work professionally in a fair environment where fairness and equality are valued. Good at socializing, project managers can build and maintain professional relationship and social capital, skilled in combining and evaluating information and facts in order to produce educate insights into the involving business situation. Project manager have analytical and scientific skill and the ability to understand project and their work, able to handle ambiguous work, project temporal and potential failure. Project exhibit a very dynamic professional identity, able to do work, make decisions, act carefully towards others, stay update and be a problem solver. Project manager can be effective in their work.
Part 2. Professional bodies in engineering. Professionals conduct. Professional conduct is the area of professional body rules, whether acting under statutory or contractual authority. Professional conduct is appropriate behavior in all settings when interacting with collegiate clients or the general public. The Code of Professional Conduct or related engineering field in Malaysia. A set of internally enforced rules or regulations that members of the profession must follow. The main intention is to ensure public safety, prevent customer exploitation and maintaining the integrity of the profession. The code may or may not have the same status as the law. Then however, the Code of Conduct set out the Part 4 of the Registration of Engineers Regulation 1990 is a legal subsidiary enacted under the Registration of Engineers Act 1967. Every registered person must behave in a respectful, responsible, ethical and lawful manner. A registered person must have performed his professional duties with appropriate skills, care, diligence and good intentions. Prioritize the safety, health and interests of the public at all times. Take reasonable steps to minimize the expected professional adverse effects of the engineering services on the environment. And lastly, a registered person shall discharge his duties to his employer or client in accordance with the case in good faith. My name is Yate, son of Alexander. My matric card number is 141020F1023. Today I am going to present about sustainability and green engineering of our title. Firstly, model of sustainable development have three perspectives: is society, economy and environment. Secondly, structure mention green technology master plan, a framework to facilitate the mainstreaming of green technology, and then strengthen the role of green economy as a catalyst towards sustainable growth. And the third, 6 key sectors focused in GTMP. The Green Technology Master Plan outlines the strategic plans for green technology development to create a low carbon and resource efficient economy. This document set out the immediate costs for the country to embark on a green growth journey. It lays the foundation of the cultivation of mindset and behavioral change to inculcate green lifestyle among the riot. This master plan is essential to facilitate the Transformation National 2050 or TN50, which is initiative to position Malaysia amongst the top countries in the world in economic development, citizen well-being and innovation by the year 2050. GTMP plays a vital role towards achieving these extensive goals of Sustainable Development Goals. Malaysia, together with other 192 world leaders, adopted the 2030 Agenda for Sustainable Development at the United Nations General Assembly in New York on 25 September 2015. This is a global commitment towards a more sustainable, resilient and inclusive development with 17 Sustainable Development Goals and 169 targets. Secondly, the SDG is a new universal set of goals, targets and indicators that UN member states will be expected to use to frame their agenda and political policies over the next 15 years with its 17 goals, 169 targets and more than 200 indicators that cover 5 dimensions, namely people, planet, prosperity, peace and partnership. The SDGs will stimulate action over the next 15 years in areas of critical importance of humanity and the planet. And thirdly, the 2030 agenda has been shaped by relevant United Nations agreements and conventions, as well as the experiences and achievements gained through the Millennium Development Goals. The Global Development Agenda spanning the period 2000 until 2015. The 2013 agenda was the result of 2 years of intensive public consultation and engagement with civil society and other stakeholders around the world. It transcends the MDGs to include wider economic, social and environmental objectives, and with a greater focus on peace, participation and inclusiveness. And fourthly, the 2013 Agenda for Sustainable Development serves as our collective blueprint to achieve a better and more sustainable future for all. The new goals are unique in that they call for action by all the countries, poor, rich, middle income countries, to promote prosperity by protecting the planet. SDGs recognize that ending poverty must go hand in hand with strategies that build economic growth and addresses a range of needs including education, health, social protection and job opportunities while tackling climate change and environmental pollution. It challenges to get serious about delivering an integrated and balanced social, economic and environmental agenda. The number 6 Economic Planning Unit is focal point for sustainable development and act as a coordinating agency on the initiatives related to SD, including the sustainable development. SDGs was one of the outcome of the Rio Plus 20, which was held in Rio de Janeiro, Brazil in 2012. The SDG was later being accepted as a global agenda for SD and known as 2013 Agenda in 2015, replacing the Millennium Development Goals. 7th, In the process to embrace and implement the 17 SDGs in a systematic and measurable manner, Malaysia has put in place an enabling environment through the following initiatives. There are established a multi-stakeholder participatory government structure helmed by the National SDG Council chaired by the Prime Minister, and held several national SDG symposiums and focus group sessions to promote awareness and participation of stakeholders, and conducted studies on data readiness and gap analysis, then undertaken a mapping exercise involving non-government and civil society organization and the private sector to align SDGs with 11 MP initiatives. Formulated a national SDG roadmap to guide implementation of the 2013 agenda and the SDGs, and implementing SDG initiative under the framework of the 11 MP. Moving forward, Malaysia will implement the 2013 agenda under the framework 11 MP, whereby the means of implementation include discover invention and innovation towards sustainability and green engineering, green technology. Measures to manage the problem of radioactive waste are borehole disposal technology. Borehole disposal technology is an IAEA recommended technology for non-nuclear power countries such as Malaysia. This technology is relatively more economical to build, safe and suitable for small waste inventories. Site space used for this purpose is minimal. The selection of suitable site in solid rock and such as granite can guarantee commitment and installations as well as prevent encroachment for thousands of years. And this is the diagram of this invention. Example of DSRS disposal illustration using bore technology. Determine the needs for sustainable and green engineering toward providing the solutions in related case. This disposal technology is relatively new, and Malaysia is proud to be a leader in this technology with the construction of the world's first bore disposal facility of the SRS. The borehole disposal facility, developed jointly by Nuclear Malaysia and the IAE, is a safe and secure radioactive waste disposal option. In addition, the government needs to enforce laws related to environmental hygiene, as this is very significant as measure to protect our environment. Secondly, methods and implementation of integrated management concept of resources and related ecosystems. Next, the landfill disposal is a practice for domestic and industrial waste disposal. The design is simple, having layers such as geotextile, clay or polyethylene to control groundwater seepage. This technology is suitable for very low level waste such as waste from liners plant with a thorium concentration content of only 6 Bg, while surface disposal involves engineered structures and is built on up to several tens of meters deep from the surface level. The long-term safety aspect is achieved through a combination of natural barriers and engineering barriers. Determine the needs for sustainable and green engineering to providing the solutions in related case. This disposal technology is relatively new, and Malaysia is proud to be a leader in this technology with the construction of the world's first bore disposal facility of the SRS. The bore-hole disposal facility, developed jointly by Nuclear Malaysia and the IAE, is a safe and secure radioactive waste disposal option. In addition, the government needs to enforce laws related to environmental hygiene, as this is very significant as measure to protect our environment. Secondly, methods and implementation of integrated management concept of resources and related ecosystems. Next, the landfill disposal is a practice for domestic and industrial waste disposal. The design is simple, having layers such as geotextile, clay or polyethylene to control groundwater seepage. This technology is suitable for very low level waste such as waste from linus plant with a thorium concentration content of only 6 Bg, while surface disposal involves engineered structures and is built on up to several tens of meters deep from the surface level. The long-term safety aspect is achieved through a combination of natural barriers and engineering barriers.
Okay, now conclusion for the radiation pollution which is happened in Bukit Merah, Perak on 1984. Radioactive waste management in Malaysia is very important because radioactive materials that have not been used need to be managed as well systematically. This is because improperly managed radioactive waste can pose a safety threat to harm to humans as well as the environment. Radioactive waste should be separated according to the type of radioisotope. This is because each radioisotope has a different half-life. Radioactive waste is first stored in a place that has been reserved for the decomposition process. Typically, radioactive waste managed at the department level has short half-life. To be sure, this reserved place should be a place away from the crowd. After the radiation level of the waste is below the allowable reading limit, it is disposed as general waste. For radioactive waste that has a long half-life, the waste is managed by an outside agency. This is because the hospital does not have a special place for the store of radioactive waste of the type. Okay, lastly, reference for this case study. We are totally referred 10 items to this case study, which is radiative pollution which happened in Bukit Merah, Perak on 1984. These are the items we are refer for these case studies. Totally have 10 items. So that's all, ma'am. These are the presentation for the engineering society case study from our group. Thank you, ma'am.